Hello guys, so we are back again, and in this session we are going to continue with the fifth part of PYQ previous year questions of JEE Mains regarding sequential series. Okay, now before starting with the lecture, okay, if you have not subscribed the channel till now, subscribe the channel, okay, and share it with your friends. So let's begin with the questions. The 21st question, okay, the 21st question which we are going to solve, okay, is this: the sum of the first 9 terms of the series 1 cube upon 1 plus 1 cube plus 2 cube upon 1 plus 3 plus 1 cube plus 2 cube plus 3 cube upon 1 plus 3 plus 5 and so on is 71, 96, 142, 192. So this question was asked in JEE Mains 2015. So the process is that we need to analyze the Tn term. Okay, after analyzing the Tn term, we can easily get the summation of how many, okay, whatever terms we want by applying summation Tn. So let's focus on the Tn, how we can get it. So here the first term is 1 cube, and here you can see 1 cube plus 2 cube, and here the same order continues: 1 cube plus 2 cube plus 3 cube and so on. So n term will be 1 cube plus 2 cube. Okay, n term will be 1 cube plus 2 cube plus 3 cube plus 4 cube and so on till n cube, right? Upon here it is 1, here it is 1 plus 3, here it is 1 plus 3 plus 5. Okay, so it is nothing but odd terms. So 1 plus 3 plus 5 and so on. What will be the last odd term? 2n minus 1. What is the sum of cube of all natural number? It is nothing but, we have studied the mathematical induction formulas, okay, for square, okay, sum of n terms and sum of cube of n natural terms. So it is nothing but n into n plus 1 by 2 the whole square upon, okay, upon what is this? It is nothing but sum of odd terms. Okay, so they are in AP. So I can apply summation, okay, formula for sum of odd terms, which is nothing but n by 2 bracket 2. Okay, first term is 1, I know, and the last term I know, 2n minus 1. So it will reduce my job. Instead of using that big formula n by 2 bracket 2a plus n minus 1 into d. So here if we simplify, n square into n plus 1 the whole square upon 4 into n by 2, here it will be nothing but 2n. Okay, so n square will cancel out, this will cancel out with this, and we are left with finally n plus 1, okay, the whole square by 4. So this is our Tn. Now we will apply summation Tn. Summation Tn will be what? 1 by 4 will be moved out. Okay, the summation will be applied to n plus 1 the whole square. If we simplify this, it will be summation n square plus summation n plus summation 1. Outside it will be nothing but 1 by 4. Sum of square of n natural number, it is nothing but n into n plus 1 into 2n plus 1 by 6. It is nothing but sum of n terms is nothing but n into n plus 1 by 2, and sum of sum of one term till n time, it is nothing but n. So we are getting this. Now what we can do, we can take, okay, n by 6 common. Okay, but instead of doing that, we want, okay, this is nothing but summation Sn. We want sum of first 9 terms, so we will apply S, substitute instead of n, we will substitute 9, which will give me 9 into 10, okay, into 19 by 6 plus 2 will nullify, and here I will be left with, okay, 9 into 10, and here we have 9. Okay, so finally what we are getting is 1 by 4, 285 plus 90 plus 9, giving me finally 384 upon 4, which is nothing but 96. Okay, so here our answer is 96, and this question was appeared in JEE Mains 2015. It was very easy question. Now let's move on to the next question. The next question is the 22 question, okay, which is this question. Let me read the question. If the second, 5th and 9th term of a non-constant AP are in GP, then the common ratio of this GP is, okay, the options are 4 by 3, 1, 7 by 4, 8 by 5. Now what non-constant means, and this question has been asked in JEE Mains 2016. What non-constant mean? It means that AP difference of any term is not zero. It will not be zero. It means that, okay, non-constant AP. So here what they have mentioned, if the second, fifth and ninth term of non-constant AP are in GP, so my second term will be what? A plus D. My fifth term will be A plus 4D, and my ninth term will be A plus 8D. Now they are in what? They are in GP, so I will apply the GP condition, which is A plus 4D the whole square should be equal to A plus D into A plus 8D. Finally we are left with, if we will open this, what we will get? 8AD plus 16D square, giving me here, if I open this, I will be left with A square, plus here I will have 8D, and from here I will have AD, so it will give me 9AD total, and plus 8D square. Now you can see, okay, a square will cancel out, and we will be left with AD equal to, this D will move here and give me 8D square. Okay, so A equals to 8D. Now I know A equals to 8D, so I will substitute this thing here. So it will give me my terms. My first term will be 9A, 9D. This will be 13D. Okay, and what will be my 12D, and my last term, which is this, will be what? It will be 8 plus 16D. Okay, so we got all the three terms. Now what we have need to find? Common ratio. Common ratio will be nothing but this term will be divided by this, so 12D divided by 9D will give me 4 by 3. So 1 is the answer. Okay, so hope you have understand all these steps properly, how we proceeded. Okay, the conditions were very simple, means this question was very easy. Okay, an average child, okay, they can also solve this question. Okay, if they have not means they have not completely did this chapter properly, then also they can solve this, because the conditions are very easy. The next question which we are going to see is this question 23rd, which says as follow: if the sum of the first 10 terms of the series, okay, bracket 1, okay, 1 3 by 5 the whole square plus 2 by 5 the whole square plus 3, okay, 1 by 5 the whole square plus 4 by 5 the whole square plus 4, okay, into 4 by 5 the whole square, and so on, is 16 by 5 m, then m is equal to 101, 100, 99, 102. Okay, and this question has been asked in JEE Mains 2016 again. Now one thing, they have given number like this, 1, okay, 1 3 by 5, okay, the fraction number, okay, the fraction numbers. Okay, the way to solve this is nothing but 5 into 1 plus 3 upon 5. So what this number will become, if this is 2, okay, fraction, okay, 2 by 5, then it will become 2 into 5 plus 2 upon 5, and so on. What will be the next? 3, 1 by 5, it will become something like this, 5 into 3 plus 1 upon 5. So you should know this. If you don't know this, you cannot simplify this and you cannot proceed further to solve the question. Now if we simplify this, what we are getting? We are getting something like 5 plus 3, okay, 5 plus 3 by 5 the whole square, plus 12 by 5 the whole square, plus 16 by 5 the whole square, plus 20 by 5 the whole square, and so on. Okay, it will go on, and it is equal to 16 by 5m. Now if we simplify it further, what we have is 8 by 5 the whole square plus 12 by 5 the whole square plus 16 by 5 the whole square plus 20 by 5 the whole square. Since 5 square is same to both of them. Okay, so 8 square plus 5 square plus 12 square plus 5 square, 16 square plus 5 square, 20 square, 5 square, and it will go on. Our aim, okay, is to analyze the Tn term. Tn term we need to analyze. Then we can get sum of any terms which we want. I know in the denominator it will be 5 square, very easy. Now here it is square. Okay, square, forget about square. My numbers are 12, 8, 16. If I take the difference of this, I have difference 4. Okay, and 4. Okay, suppose here it is n. Okay, I want to create a term which will give me 8. So I will do what? 4n plus 4. For when I put 1, I will get 8, and when I put 2, I will get 12, and so on. If I put 3, I will get 16. So in this way we can create a general term. What was the process how I created this? I just arranged the term. I know it will be square only, so I just consider the term only. I did the difference. I came to know the difference is 4, so keep the difference, multiply it into n or whatever it is required, and then add some number as per to get the first term, second term accordingly. After getting Tn, we can easily apply summation, which will give me Sn. If we can simplify it further by doing one simple thing, keeping 16 outside and 5 square outside. I will be left with n plus 1 the whole square. Okay, this is our Sn summation. Now if we simply solve it further, what we are left with is that the sigma will move inside and will give us summation n square plus 2 summation n plus summation 1. If we solve it further, what we are left with, sum of n square of n natural number, it is nothing but added to n plus 1 into 2n plus 1 by 6, 2 into n plus 1 by 2, sum of n terms, and sum of 1, okay, terms n times, it is nothing but n. If we simplify it further, we are left with this thing. Okay, why do we need to simplify? We know what we want. Okay, similarly in the previous one they want only the sum of first 10 terms, so I will substitute n equals to 10, which will give me 10, 11, this will be 21 upon 6, and here we have 2 into 10, 2 will cancel out, 11 plus 10. If we further solve, what we are left with is 16 upon, okay, 5 we will move inside, so our job will be reduced. This will become 2. Okay, this will if we simplify inside, I will be left with, if I move 1 5 inside, I will be left with, listen, here it will be 5, okay, here it will be 2, this will be 2, this will be 7, this will be 2, when 5 cancel out this, and this 2 will cancel out with this, so we are left with, okay, 11 into 7, here this will cancel out twice, so it will become 22, and here we have 2. So if I add on further all the terms, what we have is, so we are getting finally sum of this as 101. If I simplify it, okay, so if I simplify it, okay, I don't need to simplify because after this it is not simplifying only. So 16 by 5, okay, and they are telling it is equal to 16m, okay, which was 16 by 5. If I compare, I will get m equals to 101, which is the required thing. So 1 is the answer. Hope you have understand all these steps properly, because this question was easy if you know this thing which is taught in telescopic series to identify the Tn, okay, by this method, then you will probably able to solve this question easily. Now let's move on to the last question of this session. So the last question which we are going to do is this question, 24th question. If for a positive integer n, the quadratic equation x into x plus 1 plus x plus 1 into x plus 2 plus and so on till x plus n minus 1 into x plus n equals to 10n has two consecutive integer solution, then n is equal to what? 11, 12, 9, 10. Now since they have mentioned that, okay, now one thing, many children's, okay, not means many children will have doubt how it will form a quadratic equation. It will form a quadratic if you open each, okay, each these two pairs each separately. If you open this pair x into x plus 1, you will come to know it is forming x square plus x, which is also quadratic. If I here it will be 0. If I open this pair, it will also be a quadratic if you observe, okay, 3x plus 2. So like this, every term which is last term, okay, it will also be a quadratic equation. Now we came to know that yeah, it is a quadratic equation, because many children get confused by observing, okay, this series, that how it will be a quadratic equation. You have to consider each pair, then it will be quadratic equation. And in this whole function, x square is the highest power it will be, because I am getting that each pair will give me max to max x square, okay, polynomial. Now so what we can do, they are telling it is equal to 10n and has two consecutive integral solution as a roots. Okay, so let its root be alpha. Okay, if one root is alpha, and since they have mentioned that the roots are consecutive integers, so the other root, the other root will be what? Since they are consecutive, it will be alpha plus 1. Now I know my quadratic equation, okay, this is the function which I have given, has roots alpha and alpha plus 1. So substitute both the roots. Okay, the moment we substitute both the roots, we will get, when I substitute alpha, I will get alpha plus 1 plus alpha plus 1, alpha plus 2, and this will go on till alpha plus n minus 1 into alpha plus n equals to 10n. Similarly, alpha, okay, substitute, here we have substitute alpha. Now we will substitute alpha plus 1. The moment I substitute alpha plus 1, I will have alpha plus 1 into alpha plus 2. This will, okay, the moment I substitute alpha plus 1 here, it will become alpha plus 1 plus 1, it will become alpha plus 2. And similarly here it will become alpha plus 2, alpha plus 3. Okay, and like this, what will the last term? It will be alpha plus n, okay, and alpha plus n plus 1, right? And just before this, here it will be a term which will be alpha plus n minus 1 into alpha plus n. So I will call this equation 1, I will call this equation 2, and I will subtract what? Subtract 2 minus 1, which will give me, okay, the moment I subtract this from this, I will be left with alpha plus 1. You can clearly see, okay, the moment I subtract, okay, let's subtract 2 minus 1, 1 minus 2, this term will be positive then. So I know there is no this term in the second equation, so this will be left. I know this term, there is no this term in the first equation, so I know only this and this term will be left, and rest of all the terms will cancel out. So I will be left with alpha into alpha plus 1 minus alpha plus n minus 1 into alpha plus n. Okay, if I solve this, what I will get? Alpha square plus alpha minus, okay, here if I multiply alpha square plus n alpha, okay, here it will be n alpha, okay, minus n alpha, wait, we should directly multiply it. Okay, I am multiplying it. Okay, I will multiply this, it will be alpha square plus n minus 1 alpha, and if I multiply this, it will be n alpha plus n minus 1 into n. So this is the thing which we are getting. If I solve it further, what we are getting? Move the minus inside, alpha square plus alpha minus alpha square minus n minus 1 alpha minus n alpha minus n minus 1 into n equals to 0. So you can clearly see, if I open this thing also, alpha square, this will cancel out. I will be left with alpha minus n alpha plus alpha minus n alpha minus n alpha minus n square plus n. So here I will be left with this, and this will become 2 alpha, here it will become minus 2n alpha, and here it will become minus n square plus n. If I move it that side, I will be left with, here if I take 2 alpha common, I have 1 minus n, and here if I move it here, I have n square minus n. If I take n common, I will be left with n minus 1, and take minus outside this, okay, take minus outside, I will be left with 1 minus n. So this and this will cancel out, okay, so I will get what? Okay, so if we simplify this and this will cancel out, we will be left with minus n 2 alpha. Alpha we are getting minus n by 2. Okay, why alpha is becoming negative? Are you doing some mistake or what? Okay, yeah, oh shit, we have did a mistake. Instead of this term will be left in the end, we have written this term as the left. This was the term just before this last term, so it will be the right term. This will be the term here, so we have just written the wrong term, alpha plus 1. Please don't do this type of mistakes. N plus 1, that's why the answer was coming negative. Okay, so here positive alpha roots. Okay, so if we simplify this, what we are getting finally, if we simplify, it should be equal to 0. If I open this, alpha square plus alpha minus, okay, just keep this inside, alpha square plus n plus 1 alpha plus alpha n plus n plus 1 n, right? It should be equal to 0. Alpha square plus alpha minus alpha square minus n plus 1 alpha minus alpha n minus n plus 1 n should be equal to 0. You can clearly see this and this, and if we simplify it further, I have alpha minus n alpha minus alpha n minus n plus 1 into n. So here this and this will cancel out. We are left with, finally I will just multiply throughout by minus, giving me alpha equals to, okay, if I move this that side, I will be left with n will cancel out, n plus 1, and here since there are 2 alpha, it will be 2, so alpha will be finally minus n plus 1 by 2. Here also we are getting alpha negative. Let me check the answer question for a positive integer n. Okay, consecutive, here the integers are positive, so the roots can be, okay, the roots can be whatever they can be, but we are doing some mistake, okay, here. Otherwise we have continued using this and got our answer, which would be something different. So if I check, I am getting alpha equals to minus n plus 1 by 2. Now what we will do, okay, we will put this value in the general equation. Okay, what is the general equation? If you open, okay, if you observe this equation, it is, okay, it is multiplying till n times. So if you open the first one, you will have this equation. If you open the second one, you will have this equation, x 3x plus, okay, 1 into 2, and so on, it will go on. So here you can clearly see this x square will open n times, so my final answer will have nx square, and here it is 1 square, okay, it is 1, it is 3, and like this there will be odd terms, so it will be nothing but 1 plus 3 plus 5, okay, and so on, okay, all the odd, which is 2n minus 1 up into x, and the last, it is nothing but 1.2, here it was 1, okay, and the last one will have what, n minus 1 into n. So it is nothing but product of numbers, okay, what numbers, n minus 1, okay, let me write in the 1.2, 2.3, okay, 3.4, and so on till what number, n minus 1 into n. This is the thing which we are getting. Now if I generalize all the things, I have nx square. I can generalize this using summation, n summation, sum of odd terms, okay, 2n minus 1. Sum of odd terms is what? Sum of odd terms is n square. We can write it n square, sum of odd terms, so we will write here n square. Sum of all natural numbers is nothing but n square, and you should keep that in your mind, okay, that is very important thing. And here we can apply summation, it will be nothing but r minus 1 into r, from what, r equals to 1 to n. and this is the equation which we are getting. Now we have the roots alpha, which is minus n plus 1 by 2. So we will substitute here. The moment I substitute, I have n plus 1 by 4 the whole square. Here I have n square, here I will have n into n plus 1 by 2, and here the moment I open this, I will be left with what? I will be left with summation r square minus r should be equal to 0. If I open it further, I will be left with what? Okay, I will be left with n into n plus, let me call it n only, by 4 the whole square minus n square into n plus 1 by 2, right, plus n into n plus 1 into 2n plus 1 by 6 minus n into n plus 1 by 2 should be equal to 0. So if I multiply throughout and divide by n plus 1, okay, and multiply throughout by so what we will get finally? We will get finally, if I multiply, divide throughout by n plus 1 or divide throughout by n, all have n terms. N plus 1 they have all, yes, n plus 1 is there. Okay, let's first simplify. 3 into n plus 1 the whole square minus 6n into n plus 1. If I simplify this, 2 into n plus 1 into 2n plus 1 minus 6 into n plus 1. Okay, it is equal to, it was equal to 10n. Now what they are telling, wait a minute, let me check the question. Okay, this is equal to 10n, not 0, so it is equal to 10n. And here what you will get, here since 10n is there, if I multiply throughout by 2l, okay, multiply throughout by 2l, I will be left with this thing and divide by n. So I will be left this thing, and here what we'll have is nothing but 120. If I simplify it further in the next page, I will be left with 3 into n square plus 2n plus 1 minus 6n square minus 6n plus 2 into 2n square plus n plus 2n plus 1 minus 6n minus 6 equals to 120. If I further simplify it, I have 3n square plus 6n plus 3 minus 6n square minus 6n plus 4n square plus 6n plus 2 minus 6n minus 6 equals to 120, giving me n square equals to 121, n equals to 11. So n equals to 11 is our answer. Is there any option? Sorry, this was the previous question. Where is the question? So yeah, there is n equals to 11 option present there, which is the first. Okay, so hope you have understand. And this was, okay, in this session we are going to do only this number of problems. Okay, and in the next session we are going to do, okay, end the previous year JEE Mains question, because that is probably going to be the last lecture of JEE Mains previous year problem solving course. Okay, so take care, see you in the next video. Thank you for watching the lecture.